Hello everybody. So in this video we're going to look at geometric sequences. In a geometric sequence, each term is obtained by multiplying the previous term by a constant which we'll call r, and r is a common ratio. The nth term of a geometric sequence, with the first term of a and a common ratio of r, is given by the nth term is equal to a multiplied by the common ratio raised to a power of n minus 1. And I'll give you an example of how this works. If we look at the geometric sequence 1, 2, 4, 8 and so on, we can tell it's geometric because 1 multiplied by the common ratio, or in this case 2, makes 2. And the next term, we're multiplying the previous term, the 2, again by the same common ratio, and 4 times 2 is 8. So in this example, the common ratio is constant, it is 2, and the first number, a, is 1. So the nth term, un, would be a, 1, multiplied by r, 2, to the power of n minus 1. We can simplify this, so un is equal to 2 to the power of n minus 1. And we can show how this works. If we say that n is equal to 3, well in this case, u of 3, the third term in the sequence, will be equal to 2 to the power of 3 minus 1. 3 minus 1 is 2, and 2 squared does make 4. And you can see that 4 is the third term in this sequence. Okay? So in example 1, which of the following are geometric sequences? Well, for example A, we can work out the common ratio as 2, and we can see this is constant because the next term is always the previous term multiplied by the same 2. And the a value is our first term, which is 2. So we know that this is geometric. In our next example, well, if this was geometric, we would multiply the 3 by the 2 to make 6, and then the 6 times 2 would make 12. But we have 9, and 9 times 2 is then 12 is 18, so this is clearly not geometric. Actually, we can see that because it's got a common difference of 3, this is actually arithmetic. Okay, so for question C, well, the common ratio in this case would be a half, and a half of 2 is 1, a half of 1 is a half, and a half of a half is a quarter. So this is geometric. And the a value would be the first term, which is 4. And for example D, we have this negative 1. If we multiply it by negative 1, and then the next term by negative 1, and the next term by negative 1, we can see the common ratio is constant, it's negative 1. And the a value would also be negative 1. So this is again geometric. Okay? In example 2, we're going to look at finding the nth term of geometric sequences. Okay, so for example 2, for each sequence, find the nth term and then use the nth term to find the 8th term. So we'll use this formula. The nth term, un, will be equal to a, and for example a, this 2 is our a value, so a equals 2. The common ratio would be 2 times 3, 6 times 3, and 18 times 3. So r will equal 3. So the nth term would be a times r to the power of n minus 1. And we can work out the 8th term by letting n equal 8. So now we have the 8th term in the sequence will be 2 multiplied by 3 to be 8 take away 1, 7, and this gives us 4,374. For question B, well, the nth term, we know our a value is given as 4, and we can work out the common ratio by dividing the negative 8 by 4. So 8 over negative 4 gives us the r of negative 2. So this is our common ratio. So the nth term, un, will be a multiplied by r to the power of n minus 1. And it's a good idea to write this negative in brackets. So the 8th term will be 4 multiplied by negative 2 to the power of 8 minus 1, 7, and this gives us negative 512. So for question C, we can see that A, again, is 4. The R value will be the 2 divided by 4, which is a half. So now the nth term will be 4 multiplied by 1/2 to the power of n minus 1. And for our 8th term, this gives us 4 multiplied by 1/2 to the power of 7, which is 1/32. Okay, so now we can find the nth term of a sequence. We can look at some problem solving questions. In example 3, we're being told that the 3rd term of a geometric sequence where all the terms are positive is 12 and the 5th term is 48. For part A, we've been asked to find the common ratio. So we'll begin by writing down the nth term of a geometric sequence. Un is equal to A multiplied by R to the n minus 1. And we're told that the 3rd term, so this is when n equals 3, of a geometric sequence is 12. So U3 will equal 12. So we can substitute these two values into here. We get 12 will equal A multiplied by R to the 3 minus 1, which is R squared. And we've also been told that the 5th term is 48. So now we know that n equals 5 and U5 is equal to 48. Well, now we can say that 48 is equal to A times R to the 5 minus 1, R to the 4. And now because we have the same A in both formulae, if we were to divide equation 2 by equation 1, then the A's would cancel. So if we've got 48 is equal to A times R to the 4, we divide this by 12 is equal to A times R squared. Well, 48 divided by 12 is 4. A divided by A will cancel to make 1. And then R to the 4 multiplied by R squared, using the rules of indices, will become R squared. The 4 take away the 2 will give us 2. And because we're told that all the terms are positive, we know that R will equal positive 2 rather than negative 2. So now we know R, we can substitute this into equation 1. So 12 will equal A multiplied by 2 and replaces R with a 2 squared. So 12 will equal 4A, A must equal 3. So now we've got the 1st term, we've got our common ratio, we can work out the 8th term because U8 will be equal to A times our R to the 8 take away 1 to a 7, and this gives us 384. So this would be the value of the 8th term in this geometric sequence. Okay, let's try one more example. So in example 4, we've been given the numbers 4x and x plus 24 form the first 3 terms of a geometric sequence with all positive terms. So if I write this out, we've got 4x and x plus 24. We've been told that it's geometric, so we'll have the common ratio. 4 times r will make x, and x multiplied by r will make x plus 24. So because this r is the same value in both parts of a sequence, we know that x plus 24, when divided by x, so this r here, will be exactly the same as x divided by the 4. We can solve this equation by multiplying both sides by x to move this to here, and by multiplying both sides by 4 to move this one up to here. So So now we get 4 lots of x plus 24 will equal x squared. We can expand out this bracket. We get 4x plus 96 is equal to x squared. And then we can make the quadratic equal 0. So x squared minus 4x minus the 96 will equal 0. And we can factorize this quadratic to give us x minus 12 and x plus 8. So our x value will either be 12 or negative 8. But we're told that the sequence has all positive terms. So x must equal 12. So finally, for part B, find the nth term in the sequence. Well, u8 will equal a, our first term 4, multiplied by r. We can work out r because if this is 12, then we know r must be equal to 3. So 3 to the power of n minus 1. And we know that n is 8, so 4 times 3 to the 7 gives us 8,748. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.